If you are watching this video for the first time, make sure you are subscribing to Anantha Lakshmi Academy. Once you click on the subscribe button, you will see a bell icon. If you click on that bell and click on all, you will get to know whenever I upload a video. This will send you a notification. Hello everyone, welcome back to Anantha Lakshmi Academy. I am Anantha Lakshmi and today going to teach irrational number concept, exercise 1.4. Even before this, we have already covered the real numbers first exercise, second exercise and third exercises and the corresponding concepts in the earlier videos. If you are directly coming to this video, please make sure to watch the earlier videos as well to have a better understanding. If not, I'll be attaching those links in either in the description or in the end card. Please go through them. So let's go to the today's concept, irrational numbers. In this concept, we will be figuring out what are the irrational numbers, how to prove that a number is irrational. Even before this, in the very first part, when we are discussing about the number system, we have discussed about rational and irrational numbers. For that, we said that irrational numbers will be in the form of P by Q. And rational numbers are of two types. One is terminating and the other is non-terminating and repeating. When it comes to irrational numbers, we said that the numbers which can be written in the form of P by Q and the decimal expansion is non-repeating and non-terminating. Okay, those are called as irrational numbers. Even before getting into the exercise 1.4, I would very strongly recommend you guys to go through the examples. If you go through the examples, I'm telling you, there is no need of any teacher for you guys to solve exercise 1.4 because examples are exactly given in the exercise problems. Alright, if you haven't gone through the examples, just pause this video right now and go through the examples. If you have already gone through, let me show you how can we solve those problems. All right, let's get into the exercise problems. So within the exercise, I am trying to solve the very first problem is the fourth bit. This is exactly the replica of the example. If you have already gone through the example, you will be able to understand this very easily. If you have not gone through it, please make sure not to skip this problem. All right, if you have already gone through it but not able to figure out what exactly they are trying to say, then please follow this. All right, so first thing is they are asking us to prove that the following are irrational. This is the first problem. Within that I have taken this. Okay, they are asking us to prove it as irrational. So let me consider, let root 5 be rational. Alright, let root 5 be rational first. What is a rational number? Rational number is something which can be written in the form of fraction a by b or p by q, where q naught is equal to 0 and p and q are coproduct. Isn't it? Isn't it the same thing which we have learned in the last video? Yes. So let's go through it. So let root 5 be is equal, once it is rational, it should be in the form of a fraction, right? Where a comma b are integers. Alright, now I have a square root on 5, right? Let me do a squaring on both sides. Squaring on both sides. So what happens now? Root 5 whole square is equal to a by b whole square. 5 is equal to a square by b square. Now what happens if I take b square is equal to a square by 5? So 5 is dividing a square. Alright, what does this say? From here, I am going to take you to a theorem which is there even before this exercise. So listen to this concept carefully. These problems look like they are complex, but they are quite easy provided you need to know the logic behind it. Okay, so listen to me carefully. I wrote b square is equal to a square by 5. Now, what I am trying to say is 5 is dividing a square. Alright, 5 is dividing a square. So, can I say that 5 divides a? Let me repeat. 5 is dividing a square. When 5 is dividing a square, can 5 divide a? Let me give you an example. So let me write the example here. Say for suppose 5 is dividing a square. Let me suppose a is equal to 5. Okay. What happens? 5 is dividing a square. 5 square by 5. Is it divisible by a square? 5? Yes, 25 by 5 is divisible, which is 5. Now, what I am saying, when 5 divides a square, 5 in turn divides a. What is a? 5. 5 by 5 is equal to 1. So, 5 is dividing, when 5 divides a square, 5 is also dividing a. Isn't it true? Yes, that is one of the theorems just before this exercise. Okay, so now what I am trying to make out is, here 5 divides a square, hence 5 divides a. Okay, now let a is equal to 5c. Now I am thinking that a as 5c. So substituting this value in equation 1. Substituting a in equation 1. What happens? B square is equal to, what is a? 5c, right? 5c square whole square by 5, which in turn can be written as b square is equal to 5 square is 25c square by 5, which is nothing but 5 5s are. Now what is c square? C square is equal to b square by 5, isn't it? So what is happening here again? 5 divides b square. What can I make it from the theorem which we have learned? Now 5 divides b square, hence 5 divides a. So let me write it. Now 5 divides b square, hence 5 divides b. Alright. Listen to this problem carefully, do not skip this. Okay. Now what did I say? 5 divides a, 5 divides b. Alright. For a number to be rational, what did we say? It should be in the form of a by b, and a and b should be co-prime. What is co-prime? When I say two numbers as co-prime, there should be only one common factor for them, which is 1. Alright. When we say a and b are co-prime, for a and b to be co-prime, they should have only 1 as common factor. Now what happened? By the process of simplification, we figured out that 5 divides a and 5 divides b. Hence 5 is a common factor to both a and b, isn't it? So a by b cannot be rational because they are not co-prime. So both a comma b have 5 as common factor, isn't it? But okay, I have written but both a and b have 5 as their common factor. So our assumption, root 5 is equal to a by b. Can this be rational now? No, because this cannot be rational. Why cannot this be rational? Because a and b have a common factor other than 1, which indicates they are not at all co-prime. When you have written a fraction saying where numerator and denominator are co-prime, then that is not going to be rational. Hence, root 5 is irrational. This is the same concept which has been applied for the examples proving root 2 is irrational and root 3 is irrational. If you have already gone through root 2 is irrational, root 3 is irrational, then root 5 is irrational, you can do it by yourself. This I have taken because most of the students feel it a little complicated. Why are we doing this? Why not in the other way? This is the logic behind this. So first, we assumed root 5 to be rational. But when we assume root 5 to be rational, it should be in the form of a fraction where a and b are co-primes. Alright, now squaring on both sides, we figured out that a has a factor 5. Now I have substituted a value for a. Now the question should come up. If you are listening to the class properly, now the question should come up. Why did we substitute a is equal to 5c? Why not 2b or something else? Because we figured out that a has a factor 5. So a should be divisible by 5. Then whatever the value that we are assuming should be a multiple of 5. C is a constant here. That is the reason I have taken 5c but not any other value. Alright, that is also clarified. Now we figured out that b also has a factor which is same as 5, and since a and b should be co-prime, there should be only one as their factor, but we figured out that 5 is another factor, hence they are not co-primes, and root 5 cannot be rational, hence root 5 is irrational. Alright, that's what we have tried proving this here. Let's jump into the next problem. Yeah, so here this is the fifth bit in the first problem. They are asking us to prove as 3 plus 2 root 5 is irrational. So let the same way we assume that this to be rational first. For a number to be rational, it should be in the form of a by b. We will equate this to a by b, and then we try to prove that this is irrational. That is the technique for all the problems in this exercise. All right. So let 3 plus 2 root 5 be rational. Alright, then what it becomes, 3 plus 2 root 5 is equal to, it should be in the form of a by b where a and b are co-primes. Now 2 root 5 is equal to a by b minus 3. Throughout this exercise, what we have to prove is that we need to have a square root of a prime number on one side and rest of the thing into the other side. So when summation of rational or irrational numbers is given like this, you have to make sure you have the square root on the one side and the rest of the numbers on the other side. So here that is what I am trying to do. So root 5 is equal to a by b minus 3 by 2. Alright. So this becomes a minus 3b by a minus 3b by 2b. Alright. What does this become? When we assume that for a number to be rational, it is in the form of a by b. Now when a by b is rational, a minus 3b by 2b will also be rational, isn't it? Let me write the same thing. When a by b is rational, a minus 3b by 2b is also rational. So, as per that, root 5 is equal to something which is rational, which indicates that root 5 is equal to rational. But in the very beginning of this exercise, when I was solving fourth problem, we figured out that but root 5 is irrational. When we say root 5 is irrational, but a minus 3b by 2b is rational. That is what we said. When a by b is rational, a minus 2b. So, root 5 is, we know that root 5 is irrational. So, a minus 3b by 2b cannot be rational as per this, because this is equating to root 5. So, this contradicts. What is a contradiction? What is the contradiction? First, we need to know why am I writing this word contradict. A contradiction is nothing but when you make a statement as yes. Now, you are making a statement as no. Exactly opposite to this. That is nothing but contradiction. Okay. So, what we thought 3 plus 2 root 5 be rational. we thought this is rational and hence we arrived at this. So the assumption of 3 plus 2 root 5 is rational is not true. So this contradicts our assumption, which implies, so this cannot be true, right? Because root 5 is irrational, that's what we know. Hence 3 plus 2 root 5 is irrational. Alright, this is about fourth and fifth problems in this first bit. The very first bit is 1 by root 2. Even for that, you have to equate you have to assume this is rational, and for it to be rational it is equal to a by b. Now you have to get the root 2 to the other side and this becomes b by a. If you have seen in the examples, root 2 is already irrational is what they have proved. So if a by b is rational, b by a also will be rational, but this contradicts that our root 2 is irrational. Hence we can write that root 2 is irrational and 1 by root 2 is also irrational. Okay, that way you could solve it. The second and third bits are also the same way. When you are given something in this form, you have to make sure you are having the square root of the thing on one side like this and rest of the things onto the other side, and then you have to solve this as an example. Alright, that is about the first bit. If you still have problems with first, second, third bits, let me know. I would be solving them in the later videos. If you request me to do it in the comment section, I will definitely upload a video of discussing the same problems. Alright, let's jump into the second problem. So the second problem. So this is the second problem here, wherein prove that root p plus root q is irrational where p and q are primes. Given that p and q are primes, let us assume p is equal to 2 and q is equal to 3. So what does root 2 plus root 3 become? Root p plus root q become? Then root p plus root q is equal to root 2 plus root 3. Alright, let us assume. How do we solve the problems like this? First, in order to prove it to be irrational, we assume that this is rational. Let root 2 plus root 3 be rational. How can that be rational? When it becomes equal to a by b. So let me keep root 2 on one side and this is equal to a by b minus root 3. Now, so here root 2 is equal to a by b minus root 3. Now squaring on both sides. What happens now? Root 2 whole square is equal to a by b minus root 3 whole square. Alright. Now I'll be writing it over here. Root 2 whole square is 2 is equal to a square by b square plus root 3 whole square minus 2 root 3 a by b. I just have expanded the formula of a minus b whole square. Alright, a minus b whole square is equal to a square plus b square minus 2ab. That is what I have expanded. So now here 2 is equal to a square by b square plus 3 minus 2 root 3 a by b. Okay, if I send this to the other side and get this side, this becomes 2 root 3 a by b is equal to a square plus b square plus 3 minus 2. 3 minus 2 is 1. Alright, root 3 a by b, 2 root 3 a by b is equal to a square plus b square plus 1. Okay, now how do we solve these equations that when we are doing especially irrational problems in exercise 1.4? What did I tell you? We have to have the root 1 on one side and rest of the thing should be sent to the other side. All right, so I'm trying to do the same. 2 root 3 a by b, this is, I just want to have root 3 a by b first. I am sending 2 on the other side. That becomes a square plus b square by 2b square. I just took the LCM. Okay, now what happens? Root 3 is equal to a square plus b square by 2b square divided with a by b. That is equal to root 3 is equal to a square plus b square by 2b square into b by a. This is a fraction. When it goes up, b gets cancelled. That is equal to a square plus b square by 2ab. Okay, we have arrived at an irrational number is equal to something in the form of rational numbers. Now here writing the statements is also equally important. Now that we assume this to be rational and we considered it to be in the form of a by b, right? When a by b is rational, a square, anything in terms of a, whether it is a fraction, summation, squaring, product, everything will become rational. So this thing a square plus b square by 2ab is rational. But this contradicts the statement that root 3, but when you say this is rational, so root 3 becomes rational. But as per our example, we have already proved that root 3 is irrational, right? This indicates root 3 is rational, which meant a square plus b square by 2ab is rational. First statement should be like that, then which implies root 3 is rational. This contradicts. What does this contradicts? That root 3 is irrational. We have already proved that root 3 is irrational in our example problem. So when this is contradicting the statement that root 3 is irrational, our assumption, hence our assumption root 2 plus root 3 is rational is false. Our assumption is false. When this is false, root 2 plus root 3 is rational is false. So what does that imply? That implies that root 2 plus root 3 is irrational. Alright, root 2 plus root 3 is irrational. Root 2 plus root 3, when this is irrational, this implies that root p plus root q also irrational. Alright, this is how we need to solve the problem. Any problem with respect to irrational problems, we have to make sure that we have the root value onto one side and rest of the things onto the other side. First thing we need to do is we have to assume it to be rational. Once we say that, when we assume it to be rational, we will equate that to a by b, where a and b are integers and co-primes. Then as per the depending upon the situation, we will be squaring on both sides and we arrive in such a way that we get an equation in such a way that we have root term on the other side and rest of the thing in the form of a's and b's. When we assume a by b is rational, anything that is made with a by b will become rational. But the other side, when we are equating, the root term is irrational, which has been already proved, and hence we assume to a statement that this contradicts whatever the assumption we have made. Hence whatever the problem given is irrational. That is how we need to solve the problems in 1.4. They look like, when you look at the example, they look like little complex, but understand the concept, how to solve them, step by step logic. When you get it, you will own this concept, and anytime, anywhere, You will not forget this. All right. This is about exercise 1.4. Congratulations, we have finished exercise 1.4. Let's go to the concept of. In the next video, we will be covering the concept of logarithms and the corresponding exercise. Alright, till then, keep watching Anantha Lakshmi Academy, and if you feel that the content is worth enough, please share it to your classmates and your relatives. If you have any students studying in 10th class, please share it to them, and make sure to subscribe Anantha Lakshmi Academy. So wait and watch till the next video comes on logarithms. Alright, thank you.